Good evening, ladies and gentlemen. Honorable Chairperson Dr. B.M. Baveja, distinguished speakers and delegates. It's my pleasure to extend you all a very warm welcome for joining us today for 27th edition of this magnificent show, Convergence India 2019. I request all of you to please silence your mobile devices. I would take this opportunity to briefly introduce our chairperson, Dr. B.M. Baveja. He holds a doctorate degree and a BTech degree from IIT. He has, to his credit, 2 MSc postgraduate degrees, one in engineering from London University and another in public economic management from Birmingham University. Dr. Baveja joined MeitY, erstwhile Department of Electronics, in 1986 and superannuated in the year 2016 as a senior director and group coordinator from Ministry of Electronics and IT, after having worked for more than 3 decades. Presently, he is working as a senior consultant at STQC MeitY. During his tenure, he spearheaded the government initiatives of ICTE research, standardization, and infrastructure projects. His specialization is on convergent technologies including communications, broadband, network, wireless, and strategic electronics, and more recently on emerging technologies of 5G, AI, big data, IoT, blockchain, and smart cities. I would like to invite the chairperson, Dr. B.M. Baveja, to come forward and briefly introduce our panelists and take over the session, Scaling Up of Next-Gen IoT Products. Is it a good news for embedded systems industry?
Good afternoon, everybody. I'll introduce the panelists one by one as their turn of the presentation comes in. Let me give you a preamble for the session. It is my great pleasure to be here with you all, and I would like to thank the organizers once again for giving me the opportunity to be here. Subject of this session, scaling up of the next-gen IoT products, is attracting great interest all over the world. The Internet of Things, IoT, is now one of the top 10 trending technologies which will have huge market in the near future. IoT will enable and automate the process of data sharing, for it is the network of physical devices, vehicles, home appliances, and other items embedded with electronics, software, sensors, actuators, and connectivity, which enables all these things to connect, collect, and exchange data. IoT, also referred to as Internet of Everything, IoE, will eventually define and transform the way of life as we know it. As per the latest IDC report, the global spending on IoT is expected to hit almost $750 billion in 2019. Out of this, the manufacturing sector will contribute $197 billion. The transportation sector, $71 billion, utilities, $61 billion, and so the enterprise sector is evidently the largest market, whereas the consumer IoT spending will account to about $108 billion, which includes leading applications around smart homes, personal wellness, and infotainment for connected devices. The IoT spending estimated figures by the top 5 countries in the year 2020 are US dollars, $194 billion for the US, followed by China, $182 billion, Japan on $65 billion, Germany, $36 billion, Korea, $26 billion, whereas the Indian IoT market is expected to be $15 billion. According to a Gartner report, by the year 2020, more than 20 billion individual units are expected to connect with the IoT. India now has an extraordinary potential for growth of ICT in general and IoT in particular, with the adoption of the Honorable PM's flagship programs, namely Digital India, Make in India and Smart India Cities program. These major programs undertaken by the government will lead to a rapid growth of IoT industry. Under the Smart Cities project, the government plans to turn 100 selected cities into smart cities. The smart cities will be a city with all smart facilities like smart transportation, smart water management, smart energy, and so forth. This all will lead to a quick expansion of the IoT sector in India, as IoT will play a vital role in accomplishing the smart cities objective. Under the Digital India program, the vision of transforming India into a digital empowered society and knowledge economy, the aim is to take India towards the era of digitalization and to ensure that all government services are available to the citizens electronically. IoT will play a vital role in achieving this, hence representing a big opportunity for the IoT industry for it to grow and prosper. As you may be aware, Government of India, the Ministry of Electronics and IT, from where I hail, has come out with a draft IoT policy. This policy has been developed with an aim to make the IoT industry in India to reach the mark of $50 billion by the year 2020 by way of increasing the number of connected devices in India from the current 200 million to about 2.7 billion by the year 2020. As part of this policy, Government of India is funding R&D projects for specific applications in IoT, and under the policy, government is promoting venture funds which provide support to organizations in IoT related domains like memory, processors, sensors, low power devices and some electronics and solar electronics. The IoT policy supports high quality manufacturing of IoT devices in India by giving duty benefits. MeitY has also set a IoT Center of Excellence at Bangalore along with NASSCOM in a PPP mode. The vision of the Center of Excellence is to enable India establish as the innovation hub for the IoT domain through innovation, standardization, realization of prototype products, and support government initiatives on IoT solutions for specific India needs in areas like water, energy, agriculture, health, security, natural disasters, transportation, automobile, supply chain management, and smart cities. The Department of Telecom also has come out with the M2M policy and papers, and there is work going on the M2M standards and policy framework, where one of the speakers from CDOT will be highlighting the same. Now let me introduce the speakers, and I'll follow an order which we have just decided before the session. First, obviously, is the keynote speaker, Mr. Bindhumadhava, Senior Director from the CDAC. And let me read out his CV. I hope it's there in the papers. Yeah. So, Bapu S. Bindhumadhava is a scientist and Senior Director at the CDAC, which is the Center for Development of Advanced Computing from the Ministry of Electronics and IT, Government of India at Bangalore. He has been heading the real-time systems and IoT activities. He has around 30 years of industry and IT experience. He obtained his BTech degree in electrical and electronics, next to me. And he has been a postgraduate diploma in systems management, and he has several other degrees which I will not read, and his current interests are in the real-time systems, networks, internet. You think of a topic and he's covering many. He's also a fellow of the IE, which is the Institution of Engineers, and he's the IEEE and so many other chapters. And I will request him to come forward and give his presentation quickly. He has to catch a flight at 6 o'clock, so he may leave earlier also, but we won't let him leave because he's the keynote speaker. Thank you all. Welcome to the session.
Bindhumadhava and Honma So good evening. Thanks for that introduction, sir. So basically, I'll try to sort of cover up the theme of the whatever the session, scale up of next generation IoT products. So there are a lot of things here, right? One is scale up. The second one is next generation IoT. So what does that mean? Of course, always such things will be a good news for the embedded industry, provided there is a support. So my pitch will be mostly for the Indian market, because what happens is, generally we talk about the foreign markets, whatever the things are there. So what is there and what is happening, and how to sort of see that whether the scale up is possible. We say that next generation IoT, but next generation IoT always is linked up with the terminologies, right? IoT with blockchain, IoT with AI. Then current thing is basically they are trying to sort of use IoT for everything. So the only, since my CV says about 30 years of industry experience, I'm a basic automation guy. So I don't understand this terminology too much. For me, it's a control system. That's what I told in the other session also. So for me, it is a control system which was intranet earlier, which is migrating to the next internet. Suppose I push a control system on an internet, that's it. The next pitch in is the control system and the automation industry earlier had around 60% of the components, which was instrumentation, what we call instrumentation. And these were connected to mini or mainframes for doing analytics at those days. Okay? The paradigm shift is that 60% of instrumentation becomes 30% with all this so-called embedded devices, what we are talking about. Okay? So where will the 70% go? It is going upwards for all the other analytics which has to be done. So the scale up, what I see is the instrumentation which is on a larger scale, and they are connected, and you have to do some sort of a meaningful analytics on the data which is available. So that is what is they pitch in. Now what I see is, I think this is the internet reference model. That's what is there. So the physical is all sensors, which is there, and the first level connectivity, and second level what we call as level 1 controllers in the automation space. Today there is a good name given, it is called edge computing, right? And then subsequently it is taken up to the next level of data abstraction, and where all the analytics has been run, and you are going to render the output in all the small form factors which are supposed to be rendered. So that's how the whole thing is. So this is basically the architecture where the sensor is connected to what is called as a mode, and then subsequently these things are connected to a gateway, and the data is pumped on to the enterprise with whatever the minimal computing you do, and it's pushed to an enterprise system or a cloud. So these are two things which are very, very fascinating things. Now, when you process it, you can render on all these devices. It's a simple game, okay? It's only the number which matters. So what does it mean when it becomes a large and complex system? How do you model this? how do you sort of take care of so-called security? Because why I say so-called security is, we talk out of the blue saying that whether all these features are there in the security. But the thumb rule or the basic mantra is, you create a controlled environment. Within the controlled environment, you should be able to sort of see what are the protections or attacks which are possible. That is the start point. So that having this as a base, so the security also will become a easily manageable stuff when it becomes a large and complex thing. What is complex? Basically, what is the response time you require? Because today, IoT, if you see, if I say that IoT is a mobile device or any handheld, people will switch. No, 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 it's not only that. It is included in critical infrastructure also. So then they say, come out with a jargon called as IIoT, which is an industrial IoT. Then subsequently, there are newer thoughts of things what are happening, which is called as social IoT. So these are the basic three forms: consumer IoT, IIoT, and social IoT. So all these things put together, and you drive an application. So that is what is the scale-up, what we are talking of. And it depends on what is the scale at which you are going to do the adaptation. So when you adapt something, there should be some sort of a measurement. So it should improve something. What is that? So the quality of life is what is being taught. And when you adapt this into a smart city, so how does this improve the quality of life? So that is the whole thing. So basically, I just captured this. This is a Gartner's thing. It's nothing to do with me. So I just taken from there. So these are some of the basic things. What are the things? There is sensing, which is an IoT endpoint. There is communication. It can be an access point. Then subsequently, you are supposed to secure, because it is multiple devices which are connected on a network. You are supposed to secure. So this is the first thing. And then subsequently, whatever the data you get, so either in transit or in storage, you should protect it. So based on the value of whatever the data is there. And subsequently, you are supposed to use all these fancy tools of so-called AI and other tools, machine learning and blah, blah things. But it all depends on where you are going to sort of have the control and how much of computing you are supposed to do. Today, computing being very sort of not so costly, we should be able to manage large data, and we should be able to run an high-performance computing. That I'll come to the thing. So my pitch-in will be on the sensing, the computing, and what are the communications which are there, and how does this end up in a large application. So just to give a space of what are the sensors, because the sensors itself are becoming intelligent. So that means what? Basically, we are moving the intelligence onto the sensor level itself. So it depends on where you are using the sensor and how it is physically getting connected. So there is an evolution of this particular thing, and it goes without saying that so many number of sensors are supposed to come on board. So it all depends on what is the application which is being used. Now, only my pitch-in in this particular thing is basically there are multiple number of devices which are going to come, and the sensor also is intelligent device. So that is the take on this. And then subsequently there is something which is called time of the flight measurement. It is basically on the fly what you are going to sort of take as a measurement, and you do a dynamic correction. So how does these things which are miniaturized, which are called MEMS, there are some sort of roadmap for that. So the currently whatever 2015 is a micro mirror, which is available on the laptops and other things. So this is some of the sensors which are there. So now as the sensors are evolving, what does it mean? One is miniaturizing and ultra low power consumption. These are all standard requirements for a small footprint device. So what is it? It should be miniaturized, so the size should be a thing, and it should draw low power. And it should have a network interface, because otherwise it becomes a standalone embedded system. And it should be application ready data output, again, there should be some sort of a pre-processing which is done at the different levels before it lands up into an enterprise. So the upcoming sensor, this one is basic thing is the core sensing layer, the miniaturizing and integrating at the chip scale, which is the implementation, so that we can have a lot of things on the chip itself. And at system level, we should be able to connect with the standards like BLE or a mesh, which again Bluetooth mesh sort of architecture, where you require a lot of inputs. Now, the other thing is, I think there is a lot of things which are spoken about 3D imaging and system on a chip. And there is an organ on a chip also which people are talking. So, there are multiple things which is going to be done. 3D has become 4D already in 2019 Gartner's strategic top 10 technologies. So, we have to see that how these things take place. Now, the two sectors what generally is spoken about IoT, which can play a major role, is the health sector and predominantly health sector, and then there are some utilities and other space. So, in the health sector, standard thing is whether it can be having some sort of a wearable devices where we can get some information and we can do some analytics on that. The other thing is our environment. So, can we have some sort of a air quality monitoring, which is of utmost important. So, these two are the basic things which are happening. As per the 2020, the sensor technology is concerned, there are certain observations like microsensors implants, biodegradable sensors, self-powered sensors, and mostly what is happening is they are trying to see that whether we can do some sort of electronics which can behave like certain organs or certain components of a body, similar to a self-healing sensor sort of thing, if it is basically own or whatever it is. And we are trying to sort of see as small as possible the sensors which can be sprayed like a dust, and it can sort of get the information for whatever the thing it is supposed to do. So, these are some of the happenings in the sensor space. When it comes to computing, so we have seen the paradigm shift from one-to-one and one-to-many, and then sort of going for some sort of enterprise level, and now we are going into the higher end use sort of scenario where we are talking about cloud space. So, this is how the whole thing is there, and we can have some sort of edge computing based on the response time required and the application which it is used. So, we can have the computing at different level. So, as far as the transition of the computing basic paradigm is concerned, we started with so-called CPU, then microcomputer, then microprocessing unit, then we are talking about SoC, very specific to a particular application. Now, we are trying to see multi-chip modules, so that we can have many services which are there on this particular thing. This was very important because people might ask IoT with 5G. So, that is the next debate which is very, very hot, right. So, we thought that we should see the architecture of 5G and how the IoT gets married on to the 5G when it comes. So, that is the thing. So, the analytics basically is we should be able to do on either owned infrastructure or hired infrastructure. So, the basic thing what happens is today data is money. So, basically we have to see how the security is taken care. So, that is our basic thing. So, with this particular thing we should be able to see the major thrust on the data at store, that is whatever the how can you protect the data at storage thing. And it goes without saying, that is what I told the AI tool which is supposed to be used. So, these are basically for, it depends on if you are having some learning systems, how do you use the artificial intelligence onto this and how it becomes very handy. So, these becomes very handy because you can simulate a cyber physical system. Using this IoT, you should be able to simulate a cyber physical system which gives a feel of the real timeness, whatever is supposed to be achieved. So, the basic building blocks becomes very important. So, the data source is again IoT, and then subsequently how this particular thing we can use with what are the communication architectures and technologies. So, that is another thing which has to be there. Of course, there are a lot of jargons thrown at this compute space. Fog computing happens to be one of the craziest and latest thing people are talking. Edge and fog is very handy, a jargon which is there. So, that is to say with the computing. So, when it becomes data becomes larger, what is the thing what we have to see? How do we store this? So, it becomes by volume, and is there any scope for another jargon to come in, which is called so-called big data? Definitely yes, because these are all heterogeneous systems which has got different formats and resolution. How do we normalize? So, we require a high performance computing in that particular space. So, the IoT device and there is a high performance computing what is required. Now, if the application is very critical, you have to go in for high availability system, that is the redundancy and resiliency. How do you achieve that particular thing is another thing what has to be looked into. Next step is the communication. So, sensing is over, computing is over, and the third one is the communication. So, we talk about body area network or a building area network, if it is some sort of a home automation, or we look into what is called as body area network if you are into the health space. And this, if it has to directly talk to an enterprise wherever it is, or a cloud space, then you have to go on a WAN. Now, we are trying to see that the utilities and other parameters which will be on some sort of a caring basis. So, whether you have to have some sort of a data sharing, having a near neighborhood area network, so that you can sort of have this whatever the informations taking place between each other. Especially one small example is if there is a hospital somewhere nearby and the patient is at home, if he is having a wearable device, can I throw the information onto the hospital information system, and then subsequently the rest of the things are taken care with some sort of a workflow. So, that becomes important, but the major thing is the interoperability. So, the scaling, the major thing is it should be interoperable and it should be secure. And these are all some of the standard technologies which are in space. So, how these can be connected and how these based on the signal strength and the application you can scale this particular thing. This slide is just to say that the transition is happening from 4G to 4.5 or whatever it is, and then subsequently 5 or 4 to 5. So, there is a debate which is going on. So, there are some test beds and other things. Only this particular thing has been put to say that as number of devices increases, the M2M standards which are being thought of and regulated can be sort of used, so that the interoperability issue is taken care. Of course, the Wi-Fi, BLE and Zigbee and 6LoWPAN, these are all some of the things which are happening. The LoRa is the hot thing which is happening, LoRaWAN especially for the LAN protocol, because what is happening is the devices are very close. Like in the morning also we were telling, when you switch on a Wi-Fi in this particular room, you can catch up so many devices. So, whatever the communication which has to happen with the closest nearby this one, we should be able to sort of use low range communication. But having said this, there can be some sort of a distance limitation which has to be overcome. How do we see that? So, the other odd topic which people have been debating is the NB-IoT space. So, that has to be seen. This gives a good distance which it covers. So, that becomes to say that it does not have multiple hops. So, you can sort of nearly emulate a point to point sort of thing. So, this is being mostly thought of, and especially the IIoT space, where the meters which has to be connected to a AMI sort of thing, which is the automated meter infrastructure which is being thought in smart grid. So this becomes important. How much time, sir? Okay. So this is some, this one to say that how do you select? Because what happens is, in the morning also there was some debate which happened saying that there are plenty of communication thing. How do I select? So it based on your this one. Two factors are always involved. So whichever is fancy can be selected. One is the high capex and low opex. Okay, high capex and low opex, and the reverse. So the net to the consumer or the user is same. So you should have that particular thing. So if you have got upfront, you can shell out. That is one thing, and the other thing is the opex. So it all depends. Both the things we are having a difficulty if the interoperability or the co-location of the legacy system with the new standard systems, if it is not achieved, the whole thing again you have to go for a revamp. So that is the only thing which has to be thought of. These are all some of the technologies which are sort of already tried, tested out, and which is in space already. So now, how do we see 5G on IoT? See, actually what happened is now almost we are not paying any money for the voice, right? I mean, the tariff, if you see the breakup, it's 0 voice and huge amount for data. So what happens next? They might say data is also free. So subsequently, where do they get the thing? So the critical, this one is the value added services which comes with this particular thing. That is where we are going to head with. Of course, for having a good value added services, the quality of service becomes an most important, and there is a premium attached to that. So all these things come into the thing. So the latencies are the major things which has to be looked into, and the speeds also has to be looked into, which are giving better specifications on the 5G. So that is why people are trying to sort of catch up with integrating devices onto 5G and or making it compatible with 5G thing. So that's how it has to be seen. Now, having seen these 3 C's, right? I mean, sorry, not sensing, computing, and communication. So let's see the applications. What we are talking. Applications are generally, these are the things which are spoken. One is the retail, the healthcare, the energy, the building, and mobility, education, and transport. Mobility is another thing. The whole thing is the application. So if you are seeing, there is inter-application communication also which is there, so that you can have some sort of a thing. So the data devices, whatever the thing are there, it's not only IoT, there are other soft inputs also which are available. So smart city is one thing, there is some statistics for that. This health is another thing. Smart grid as a utility in the power sector is one thing. So basically increase number of data sources, like the chair was telling, internet of everything. So it's not only things, it is internet of everything. So increase in usage of AI in the application is a major thing. Future application gets the data from multiple sources. So you have to see how to validate it, rationalize it, and then collate it and make a meaningful information on that. How do we scale up of the data source and the hybrid network? So because it's not a heterogeneous system what will have, either the network or the sensors or the communication or whatever the things, it's always a heterogeneous space. So how do you sort of rationalize and look into this? And since IoT is there and people are there, privacy and security becomes important. Security is again infra, information, and application. So these are, we have to bifurcate all these things and look into the thing. This is what I thought I will sort of present, and I thank the organizers for giving me this opportunity. Thank you.
Thank you, Bindhumadhava. You gave a very interesting talk on the vital components of IoT, starting from the sensors to computing and communication. And you explained how we have moved from the evolution of sensing technologies. Then you talked about the computing going from AI to fog computing, and finally the communication to the interoperable and the secure IoT devices, and the protocols going from LoRa to the IoT, narrowband IoT. And finally, you explained about the 5G, which is the upcoming technology, and IoT is going to explode with the 5G happening. So now I'll request the second speaker, Mr. Sanjay Gupta. He is the Vice President and India Country Manager in XP, which he is spearheading 3 diverse R&D locations, Noida, Bangalore, Hyderabad, and has about 1,800 employees. He has earned engineering degree in electronics and communication from DCE and MBA from the ISB Hyderabad. Mr. Sanjay Gupta.
Thank you very much. Good afternoon, everyone. It's a pleasure to be here, and I want to thank organizers for having me in this prestigious conference. In next 10 minutes or so, I will try to cover a technology perspective and how things are moving in this fast-changing IoT world, and what innovations in various fields are going to be instrumental in driving the way forward. So let me start. But before I start, I genuinely feel humbled that we are actually in a very, very big, incredible opportunity, and the wave that we all are into, it's a lucky for us. And the chart that you see actually indicates the biggest invention possibly that happened with the invention of wheel. As per the historical facts, it was close to 4,500 years ago. And there was almost a lull of 3,500 years when there was absolutely no invention. So think about the mankind who literally spent a life which was very boring without any change for generations after generations, until the first big change we saw at the beginning of 18th century with the steam engine invention, and that radically changed the way humans work from a slave labor into some kind of an industrial revolution that started. The key thing to note here is whether it is a 18th century beginning or 19th century beginning with the second major revolution of electric grids and invention of automotives later on, and eventually the digital world with the invent of semiconductors in the mid-90s. Somewhere India remained aloof from the whole journey that happened from 1700 onwards. And just to give an interesting fact, close to 2,000 years ago, if you go to the historical facts, the biggest economy in the world, any guesses? It was India. 1,000 years before, the biggest economy was India, and just 300 years ago, at the 1700s, it was India. Why suddenly India got disappeared from the world map? And one of the key reasons is actually hidden in these slides, where we missed out the first 3 industrial revolutions. And we were nowhere because of various reasons. But the point is, we are right now, today, in the digital age, and I believe it is an inflection point where we all are going to turn the history around with so many things changing in real time. When we had 100 million users for a Facebook or a Twitter, took less than a year. The same amount of users for airplane industry, or for that matter TV, took probably 15, 20, 50 years. The way world is changing, we are right in the middle, and the topic of today's conference on the next-gen IoT is actually very relevant, because I'm sure a decade later, there will be half robots here working with AI and ML-based technologies, and the world is going to be very, very different. So we are indeed in a very, very big innovation space, and we are lucky to be the part of that. The second phase is actually imagination is the key. And again, this picture, interesting picture taken in 1900. You will not see a car on the road. It was taken in New York City, April 15 of 1900. And the same city, same picture, only 13 years later, you will not see a horse. And everything happened in 13 years when the entire automobile industry was taking a birth. And that also indicates a very historical fact about how world is changing. And again, linking it back to IoT, the way things are changing, we are talking about 100 billion devices connected with each other, multi-gigs, and the figures are actually astronomical. We are talking about probably zettabytes of data. Every hour is going to be moving around. And today we don't have storage, neither the compute power for this huge data. So people say the data is going to be the next big oil, is something which is probably going to be very, very true. The third thing on the various future innovation possibilities within the IoT world. And I listed 4 things here which are very, very big trends happening from a semiconductors perspective. From a technology world, I represent NXP among the top 5 semiconductor companies, and day in, day out, we are designing chips and embedded solutions for one of these 4 words that you see around. But these 4 are probably the biggest drivers for innovation. When we talk about cloud computing, we are talking about everything in the cloud. We are moving towards performance. We are moving towards edge devices, but everything from pictures to your personal data is going to be there on the clouds. So connectivity is one big trend that is coming. Our tagline is a secure connections for a smarter world, and it has 3 very important underlined words: security, connectivity, and smartness. And that is depicted in this picture, where when we talk about cloud computing, it's not going to be possible without a very high level of security. And we talked about that in the previous presentations, how security is going to be key enabler for IoT. We might have the best of devices, but if we cannot guarantee a secure connections, if we cannot guarantee that my personal data is securely stored into either a cloud server or in my personal email box or my compute device, no matter how smart we are, it is not going to be a reality. We talked about in a previous presentation a different communication mode from a Bluetooth to 5G, 4G, and many others. This only indicates the connectivity is going to be the key piece in going forward. So while you have a security, a connectivity is going to be very important medium. The top right picture is indicating a smart. So smart connections for a smarter world, where a human brain is being depicted. And the way we say is, IoT is nothing but replacing a human brain, depending upon your application, whether it will be a partial or it will be full. But an intelligence which is not just proactive, but which is also having the cognitive intelligence, which has a context awareness intelligence, where you can actually let a device take a decision based on the context. As an example, a child in a party, if a mother is behaving differently, if a child is screaming in a party versus it's a hospital, the reaction of mother is different. And that indicates a cognitive intelligence or a context-aware intelligence. Today our devices may be very smart, but they may not have that intelligence, and that is what is depicted in a word going towards the smartness. And last but not the least, a word of autonomous driving and driverless car, which is going to be driving the future. I just want to say one thing. When we say data is the next big oil, we have more than 10 billion images which are uploaded every day, and this picture just indicates various social media platforms where data is just moving like anything, and that is going to be a big trend for the multiple IoT devices we are talking about. I have three scenarios, very briefly, 1 minute each I will talk about it, about the potential IoT space where our industry in semiconductors is working on designing the tiny chips which are going to be embedded in all of us in time to come. One is a medical application, where the scenario is a microscopic chip. You swallow, it records your biorhythms, your health statics, and if you need any medical care, it can send data automatically using a wireless communication to a doctor, and doctor can send a trigger on a dose, which again can be triggered into your blood through another chip device embedded in your body, and it can release that. This is not imaginary, guys. This is happening right now. We are designing electronic chips into this space, which is a perfect example of IoT in medical. This example, what if a car can talk to another car? Just imagine an accident happens on the road, where in India specifically 70% of people die on roads because lack of medical care after accidents. Imagine if car can automatically call ambulance. Ambulance automatically comes knowing your GPS location along with the required immediate attention and takes you to the nearest hospital because the entire IoT world is connected. We are working today on these technologies. And last example is, what if your car can talk to your home so that before you actually reach your home, your personal devices or your air conditioning or any coffee maker of your taste is ready? And these are some of the key applications we are working towards. Having said that, without challenges, this is not going to be reality. This picture is worth 1,000 words, where the software that is required in a typical smart car is 10 times more than a 787 airplane. And that indicates that how embedded is going to be important to manage software and its quality, so that we cannot mess with security or connectivity or human life. And this is a great example where if you replace a husky with a wolf. With a bad AI algorithm, you will still identify it as a wolf if the snow is at the back. So algo and AI and ML engines have to be very smart so that they have so much of training and so much of data points that they don't get confused. And lastly, the three major trends that are going to appear, data generation, the compute performance, and the network bandwidth. These are going to be the main driver. And to conclude my presentation, as an electronics, as a semiconductor company, we need to create the disruptive innovation, and we must learn to unlearn, because we are entering into an era where partnerships will be required, and no single company or individual can do it with the challenges that we are facing in this next world. So thank you so much for the opportunity, and we'll have more opportunity to interact. Thank you.
Thank you very much, Sanjay, for a very interesting presentation on the innovations. You talked about the various applications that you are developing, from the body talks to the doctor, car to car, and home to car. Those are very interesting indeed, and I'm sure you'll succeed in those innovations, and the IoT will see the light of the day. So now, before we move on to the next speaker, since Bindhumadhava, because there are a lot of Bindhumadhava has to take a flight, so we need to also get into the flight mode of asking questions. So if there are any questions for the keynote speaker, you may kindly take them. Anybody from the audience who wants to know about any kind of next generation IoT products that has been defined by the speaker?
My name is Rishikesh Chandra. I'm from Azura Tech LLP. I'm CTO of that company. So in India, like you, I mean, whatever like designs and whatever you're talking about, it was related to the country, right? So IoT also is involved with large amount of data ingestion, right? So what are we doing, or do you have any plans for having the data like controlled by the country itself, not going out of the servers? Like there are large amount of applications which we are building in India itself, but the servers are located outside India. Most of the servers are located outside India. Do we have any plans in India like to control the servers, build the servers in India itself? What do you see for that?
What is the CDAC plan on having the server technology?
No, basically what we are seeing is the application, whatever the application which comes out of this particular, whatever the things what I told, will be hosted on a national cloud. Okay. So that is the thing. So data going outside is, we have to see under what circumstance it can go out. Okay. That is another security issue which has to be seen. So there are no backdoors, trapdoors in the device itself at device level, and then subsequently in transit it doesn't go for any sort of handshake outside the country. The next level is the data at storage also. There is no cyber attacks which are possible at that. So at different levels, this has to be protected. So that is the only take on. So mostly it is security aspect which has to be seen. If it is having a large impact, so the data should remain here. If it is for academic interest, a data set can go anywhere.
Moreover, the government, as you know, the Ministry of Electronics IT is coming out with the Data Protection Act. It will cover some of your concerns in the act as well. So now you will be excused, and a memento for the keynote speaker can be handed over in between the session. Okay. I'll call upon the next speaker, Srinath Nudurupati, the founder and director of the Inxee Systems Private Limited, India. He is a graduate of BE in the domain of electronics communication, holds an MS from the Clemson University, US. He started his career in 1996, and he has a lot of passion to bring about revolutionary changes in embedded and semiconductor industry. The dynamic leader that he is, he brings out the best from his team, never setting for average. And he is going to deploy the IoT solutions in the country. So we request him to tell us about his experience and the future that IoT sees.
Yeah. Thank you so much, Dr. Baveja. It's just an honor to be here, to be able to get an opportunity to speak in front of you and share some of the experiences working in the Indian IoT industry. Although it is pretty nascent, pretty young at this time, I've been fortunate enough to be running a company which creates IoT products, which has been creating IoT products for the past 5-6 years. So I would like to take this opportunity to just speak about some experiences covering two topics. One, which is the future of wearable embedded designs, and sensors and embedded systems. So since I'm a hardcore electronics guy who has built embedded systems and devices myself, I've seen time and again so many problems which has kept us from scaling up. And the topic of today's panel is actually scaling up of next-gen IoT products. So if you ask me, where are we today? Are we doing great in the IoT business? We all talked about, like we had a gentleman from NXP talking about the various things NXP is doing in its chips. And we had the gentleman from CDAC talk about what the government is trying to do. At the same time, where are we today? Are we doing enough in terms of generating revenue in this vertical? We all know how big the mobile industry has captured, how much market share it has captured, in terms of revenue. It's a very large industry. But has IoT, although a lot of people say mobile is also a part of IoT because all the apps are being consumed there, has the IoT business itself really lived up to its expectations today, and what does the future hold? And I'm going to talk about that real quick. In terms of revenue, I would say today it's just extremely small. We talked about 30 billion devices, we talked about $15 billion in 2020, all these big numbers. But many people ask me, is it true? I just don't see it. If I have an IoT company, or if I'm going to be an entrepreneur or a company going after IoT as a business, am I seeing revenue today? And the answer is no, not at all. And the reason is there's too many problems in the IoT sector at this time, from standardization, interoperability, and whatnot. So that's what we are hoping in the next 3 to 5 years. We as an industry can come together, address all these challenges. Some of them I'm going to talk about right now. And maybe some of you can take some notes from my speech today and see maybe the mistakes I've done, maybe you don't do, so at least you're there on time to the market to sell your devices or your solutions. So under wearables, I would like to classify the future of wearables itself under 3 categories. Wearable, it stands for something which is worn, right? I launched India's first wearable GPS smartwatch in 2014 in partnership with Micromax. We launched a company called IoTex. At that time, nobody, we sold about 10,000 devices, but it didn't sell in the millions because people were not aware of the technology. The product actually was very good, but we didn't sell a lot. So that business really didn't take off, so I had to move on. So wearables itself is something which is associated with human. And when we say it's associated with human, there's mainly 3 categories of wearables. One is for safety. It could be a child safety device, or a women's safety device, or an elderly safety device, or we could have a health wearable, where the wearable itself targets the various health parameters you may want to monitor, like a heart rate, or you want to monitor somebody's SpO2 or whatnot. And then an industrial application. Nowadays, I see a lot of interest from the mining clients, people who are running mines or factories where maybe there's a lot of harmful gases. You know, they want to equip all their workers with wearables, so the workers are alerted ahead of time that there is a harmful gas present here, so do not go there. Or if a worker falls down while trying to climb a staircase or trying to climb a scaffold or something, he falls down, then you detect it ahead of time so you can take care of him. So many requirements are coming from the industry side of things. So while there's so many applications, it's just not possible for me to name the amount of requests which come to me event after event. It's just mind-boggling. One person will come and say, please add oxygen sensor along with 2G. Somebody will come and tell me, I want a LoRaWAN based GPS wearable. So somebody will come and say, I want a fall detection based wearable which will work on BLE. Things like that. So I get these requests almost every day. Believe it or not, in the last 3 years, this market has been getting so many requests, but not many manufacturers out there. It's just not there. So the reason, there's many reasons. First of all, it is the form factor. While we all have semiconductor chips evolving, still power is a big concern. Today, I don't have a 2G wearable device which can last more than 2 or 3 days. Then how are we going to create a wearable which is going to last a month? Nobody wants to charge a battery every day. So these are some of the technological challenges we need to address. So form factor is one, power consumption, performance. Like we had a bunch of gentlemen come and talk to me over this event. They said, I want to run Android apps on a wearable. I want to be able to write whatever I put on my phone, I want to be able to put it on a wearable. So performance of the wearable is also gaining a lot of importance. The functionality the wearable supports. Maybe does it have a camera? Just like a phone, you may want to have a very high quality camera. You may want to have, the wearable target various kind of verticals. So as I said, there's many different applications which drive the wearable business, and there's so many requirements from the wearable side. And from sensor side, the gentleman from CDAC had already talked a lot about miniaturization of the sensors, biodegradable sensors, self-powered sensors. It's just not the size or the technology of the sensor, but it is the application. For example, some clients have come and asked me, I want to have a breathalyzer sensor integrated with my VTS. Or we've had harmful gases. So somebody wants to detect a carbon monoxide, somebody wants to detect a methane gas, a vibration sensor. Of course, the audio and the video have always been a very big sensor for us, like the microphone and the camera. And now lately, there's a huge push towards blood pressure and blood sugar monitoring on a wearable or on an embedded device. So sensors have to evolve, and there's so many sensors which is possible to be developed. So just like the applications in the wearable, the sensor space is huge. So the opportunity is humongous. But ultimately, it all boils down to cost. So in summary, what I'd like to say is while there is so much opportunity, it becomes extremely critical for us to develop something which is cost effective, then the IoT market can adopt it. Thank you so much.
Thank you, Srinath, Nudurupati. You did outline all the challenges and bottlenecks that the sensor technologies are facing, and I'm sure all these in the IoT will be overcome in the near future when things are moving in the brighter side, and especially the form factor, the efficiency, security, all these aspects will be overcome. So let's move on to the next speaker. He is Mr. Toshihiko Honma. The spelling is Honma is not correct, so the organizers are requested to please make the correction. Toshihiko Honma, the General Manager for Global Marketing and Engineering Department from SEI, Japan. He is the Lightwave Network Product Division Head, and the Global Marketing and Engineering Department General Manager. After studying mechanical engineering from the university, he started working at SEI since 1993. That's about 26 years. He engaged in facility development, and finally, he also in 2018, he's seeing not only the R&D, but also the sales marketing fusion for the global market. He is currently engaged in developing a connected fusion splicer to enhance the slicing experience. Mr. Toshihiko Honma,
Yeah, thanks.
please give your presentation.
Thank you for. And hello, good afternoon, and ladies and gentlemen, and thank you for giving good, excellent opportunity for me, and it is great honor to introduce and our companies and our company's latest technologies. And before the presentation, I'd like to introduce myself. I'm Honma, and I'm Honma, and came from Japan, director of the technical director of the fusion splicing. And the fusion splicing is connected optical fiber by arc and equipment. And I have worked for splicing development since 25 years ago, and specializing in development splicing machine. I'd like to introduce our company, Sumitomo Electric, very shortly. And Sumitomo Electric is a Japanese manufacturing company. It's a very famous company. And our headquarters is located in Japan, and capital Tokyo and Osaka, big city. And our company has established since 80 and 97 and over and 120 years ago. And we and the Sumitomo Electric Industries have a long history of in company. And Sumitomo Electric offers worldwide, and our company branch office, many branch office worldwide, and subsidiary. And I would like to introduce our business segment. And Sumitomo Electric Industries consists of 5 business segments. First is automotive, second is electronics, third is info communication, and fourth is energy, and the fifth is industrial materials. Automotive is for the auto and vehicle companies, and electronics is for smartphone and electric company, and the information communication is the communication cable for communication carrier, and energy is energy cable we provided. And we are on the information segment working, and ICT Sumitomo Electric carries a wide range of products worldwide. And especially ICT products is fiber optical cable for communication carrier, and I worked in the fusion splicing and high definition core alignment fusion splicer to connect the optical fiber, and we are making optical fiber and low loss and ultra low loss fiber for communication, and Ethernet PON, and optical connector, and optical cabinet. And all the optical fiber components Sumitomo Electric provided worldwide. And after the session, Mr. Matsubara-san explained.
Hello. Hello, everyone.
You have another 3 minutes.
3 minutes?
3 minutes for completing the session.
Yes. So let me introduce myself. Like I came from Tokyo, and I'm working as a sales of Sumitomo Electric, and he's a technical head. And let me explain about their situation in Japan, all over the world, about the IoT. So as you know, the IoT is like a device which can emit their signal with their certain IP address. So when we calculate this IoT device in each sector, like a car, military, medical, so like this is like a heavy, like very rapid increase these days, of course, as you know. And when we try to see in each segment, what part is like a big, what is growing. So there's a graph right side. So like of course communication, like for smartphone, it requires a lot of IoT device. But please see the red circle is the industry, which is a manufacturing. And like Japan, we are very strong in the manufacturing, and we now start to produce the product with IoT devices. So we need our IoT software and device both. But so like we are growing, but what is like a challenge for us is so like biggest bottleneck is how to have enough IT resource, human resource in Japan. So traditionally we are very strong in the hardware manufacturing, but for unfortunately the software still still not so strong compared to like a IT big country like India, right? So how we can improve our software engineering power and also utilize the potential opportunity to have a partnership with other countries like India is something very important topic for us. So one successful case in Japan, I will introduce of the IoT installation in the industry segment. So do you know Komatsu? It's like a company produce heavy equipment like this. And they're now in 2001, which is like near 20 years ago, they started to install IoT device in every heavy equipment they produce as a standard package. So now over 400,000 heavy equipment is working all over the world, and they increase the market share a lot with this function. So what kind of benefit they are providing to the customers is, I explain a little bit. So like they install their equipment in every heavy equipment, and they provide the information and also absorb the information from the machine, including engine oil, temperature, speed, oil pressure. These small information all goes to the server, cloud server. Then they use these data to analyze and give a more consulting advice to the customers. So through this advice, they can contribute to customer in these ways. Sorry. So the first one, the resource management. So now each truck, they install GPS location and send the data to server. And they can remotely turn off the equipment, so they can prevent the thief. This is very big value for many countries. And also maintenance, before they face the problem, actual problem in the field, they can detect any sign of the problem, machine trouble, before. And also they can give many consulting service to the customer to reduce their cost. So it's very big success, and yeah. So how we can do, and now we are challenging in our products, which is a Fusion Splicer. Sorry. So 2 minutes. Okay. So this is very simple. Like through smartphone, we connect, absorb all the data to server, and the manager in the office can check all the information about the fusion splicing machine. And how it works is like they have several teams in the field, and they work. So now how they manage their team is like they call the phone and ask them to send their photo by WhatsApp, and then they make an Excel sheet. It's like sometimes this data is true or fake. They can modify it, right? So like to see clearly what is happening in the field is very important to improve the efficiency of their team, like team management. So we provide this service and make customer happy. Actually, it's happening in India these days. So, so we face many another requirement from the customer. How to meet their requirement still require the speed of the development of our software. And for this, we have smartphone application, there also website, but in Japan, it's a shortage of the IT human resource. So I personally think our company need to think about the outsourcing of this to India. But for Japanese company, what is the challenge is our business style is very different. The culture is also different. And how we can communicate in a very efficient way, smoothly, with Indian IT vendor is a very big challenge, you know. So if there's any IT vendor,
Takashi,
sorry,
you will have to end.
So
come to the conclusion.
Yeah.
Okay.
So my conclusion is there's a big potential for Indian IT vendors, especially for this industry segment for IoT. Okay. Thank you very much.
Thank you, Mr. Takashi and Mr. Toshihiko. You gave a very interesting outline of your company, and we saw that how you're progressing in the field of splicing units and how the shortage of IT resources, India can cooperate with you for the software development part. And of course, the embedded systems, you're having the specialization in the hardware. We will help you out in the software. I'm sure the audience, some of the members will be interested. Those who are visiting the exhibition, they'll come and visit your stall and we'll have discussions. Thank you very much. And now we come to the last speaker, Mr. Aurindam Bhattacharya. He is the group leader from CDOT, and he is an electronics and communication engineering graduate of 87 batch. He has vast experience in computing and communication, and he started his career from ECIL. Then he has moved on to I think CDOT straight away from ECIL, and finally he is the group head for the technical services for the CDOT. And I'll request him to give a presentation on some of the IoT and M2M aspects. Thank you.
Yeah, thank you very much, Mr. Baveja. Yeah, I understand. I mean, keeping the interest alive, being the last speaker is slightly difficult and something of a tall order, but I'll try to do justice as much as I can do. Okay, my name is slightly misspelled, it is Bhattacharya with an A at the end. Okay, so I think our keynote speaker, Mr. Bindhumadhava, set the tone right by giving a perspective of, okay, thank you. By giving a perspective of everything that is included in the IoT paraphernalia. He talked about embedded devices, embedded systems, talked about gateways, talked about applications in the cloud, and the communication network. One thing, if you had noticed, that he spoke about this IoT thing taking, kind of shape in the industrial segment in the very beginning. So it was automation and industrial automation which actually paved the way for IoT way back when we started automating the processes, the manufacturing processes. I'm going to talk about something entirely different. I understand Mr. Sanjay Gupta talked about the inflection point. And if you see this graph is from Statista, market research company. If you see till 2019, we were hovering around 26.6 billion devices. So almost a linear from 15.41 billion in 2015 to 26.66 in 2019. Suddenly, it has been a linear growth. Suddenly, it is expected to take an exponential rise from this point onwards. So clearly speaking, this is an inflection point. And this is the time when we should be more aware as to what is to be done. So long we have been doing things, or we have been accepting things the way they came. We kind of rode the wave, the IoT wave or the M2M wave. But are we doing the right thing? The topic of our panel discussion is it a good time for the embedded industry? The answer is yes, obvious yes. There cannot be a no. With so many devices, we are talking about billions and billions of devices. We are talking about somewhere around 75.44 billion devices in the future. So it's definitely wearable devices. Everywhere you will see embedded devices, embedded electronics. And he talked about medical devices going inside our body and communicating to the doctor. I mean, a little scary though, but definitely exciting as well at the same time. But having said that, are we doing the right thing? Another slide. Now, if you see IoT M2M, who are the maximum consumers? So two of the biggest consumers in today's world are smart cities and industrial IoT. Now, these are global figures. So you see the connected health comes the third one over here, right? And then connected cars is the fifth one. But in India, with so many cars plying on all our roads, Delhi, Mumbai, all metros are congested to hell. We don't want to live in these cities with such number of cars. But you have to accept it. They are going to be there, and they are going to be connected. So what is it that should worry us? I'll ask you to park this question. See this slide, the issues which are plaguing, I'm sorry for this is going a little away from, the issues plaguing the IoT M2M ecosystem. So these are basically the issues, but just bear with me for one moment. I'll give you one small example of a IoT solution in a car. It all started with the premium cars, which used to come fitted with the sensors, and those sensors used to transport data using a GSM or 3G, 2G kind of technology, GPRS, back to their factories, way back in Germany. So you asked a question about our data going outside India. So it is actually a reality. Most of the IoT data which is coming from foreign companies actually go out. And you yourself are actually giving the IoT data outside our country by subscribing to Google Maps and the applications that are provided on your mobiles. So we did not give a thought to the whole ecosystem, that the enormous amount of data that we are generating and pushing to the clouds, even including Azure, Microsoft Azure, is actually giving the data outside. So AWS, Microsoft Azure, they are giving it for free. Nothing comes for free. All that data that you are pushing to them is actually benefiting them and shaping their applications, which are not going to be cheaper in the years to come. Now the issues, security. Somebody talked about security, security of the devices. We talk about security, we talk about secure communication and all that. Can anybody say how many devices are currently deployed in any city in India? So many smart cities have been done? You cannot, because there are no figures, because they are all working in silos. They are all working in different verticals. Industrial IoT guys are doing in their way. Health guys are doing their way. Everybody is putting up devices, and everybody is putting the same way as Mr. Bindhumadhava had put it. Some sensors, transducers, put some controller, microcontroller, microprocessor, whatever, take a communication network, use it as a means of transport, send the data to the server. The server most likely, because everything nowadays is very attractive to be pushed to a cloud, because the services are free, push it to a cloud and receive it on a mobile app. Mobile app development is very easy and it can be done by school students, they do it. So you get it on your fingertips. You're happy, they are happy selling services, you are happy because you're getting information. But at the same time, you are basically giving a lot of information to people you don't intend to, because it is not done in a standardized fashion. It is not done horizontally. Mind you, I was going to give an example. These connected cars, if suppose I want to get this data shared between multiple divergent applications. How divergent? The car manufacturer is not servicing your car, right? The servicing partner is somebody local. He never gets to know how your car is being driven, what element of your car is failing, how you are driving that car. Now, in case he gets this information, he doesn't want all the information. He only wants a subset of the information that is generated from your car by all the sensors that have been put in. If he gets access to this particular information as to what is failing in your car, he can prepare for his logistics in a much better way. The insurance company who you subscribe to get your car insured, if he happens to know how you are safely driving your car, he may charge much lesser to you for your insurance premium. Or the false claims that people put in can then be done away with. So only the valid claims will go. So naturally, the valid claims go, the insurance premium, the total cost would come down, so your premium will go down. The traffic policeman, if he happens to know where your car has broken down, or your on-road service assistance guy, if he knows that where your car has broken down and what has broken down, he can give you much, much efficient service. But it is not going to happen because everybody is required to put their own set of sensors, because the data that the manufacturer had put in by virtue of putting their sensors is not shared. And why it is not shared? Because it is not standardized. In order to share the data, you will have to tie up with the application provider to the manufacturer and have a layer on top of it to access that data. And will it be secure? No, it is easier said than done. Now, no sharing of data, device ownership. Today, you don't know who owns a device. So, device changes hands. You are never sure. The device, it can masquerade. Somebody can take away a sensor. Suppose you are putting a home sensor, your home gateway, home security system, and you are moving out, your mobile actually communicates with that device. Somebody can simply replace that particular device without your knowing and can send the data at the back end to somebody else. Would very clearly know when you are moving out of your house and when you are entering. So he can very well plan a theft. So many addressability. So what is the solution? We talk about standardization, and every time we talk about standardization, we get into this cobweb of talking technology. LoRa, Sigfox, this, that. These technologies will continue to evolve, and we don't get into this space talking about these standards. They are standards, fine. But those standards are there in a different segment. We call a PAN protocol or a home area network or a personal area network. These are wireless technologies. They will continue to evolve. I'll just take 3 minutes, 3 minutes more. So what we are talking about is an architecture which is horizontalized. Let there be a horizontal architecture, a horizontal framework which is agnostic to such technologies underneath. Let it be the security framework, let it be the networking technologies, and it should give a connectivity which is universal pluggability by applications, devices, networks. So any network, be it NB-IoT, be it LoRa, Sigfox, Zigbee, Z-Wave, anything, should be pluggable to this common horizontal framework called a common service layer. So play in this segment, play a common. And believe you me, many people are still not aware that a global standard exists. So from this vertical siloed kind of a application deployment, we are talking about a horizontalized deployment, wherein the converged ICT infra will actually enable you to plug all such M2M devices and associated applications through their gateways to talk to this common service layer. So you have interoperability. Today's smart cities have got smart street light everywhere, or smart garbage waste management system everywhere. They are talking to one application. Now, nobody buys the lights for the entire city. What if you are going to buy another set of 10,000 or 1 lakh lights in that particular city? You are tied up with that vendor who had provided you the earlier kind of solution. So these solutions are not sustainable, these are not futuristic. You need to have a solution which actually is scalable, which is futuristic, which is long running. And without this kind of a common service, without a standardized common service layer, this is not going to be possible. So one need to take notice of this. It's high time that we take notice of this. Otherwise, we will get into a vendor lock-in situation and will never be able to recover from that. So we are creating cocoons in the, so what I'm talking about a global standard, which is basically formed by 8 SDO, standard developing organizations. They are not manufacturers, they are not industry bodies, they are standardization bodies who actually created the standards, and there are 200 plus organizations who are members of these standards contributing in the standard. They are open standards. The specifications are available free of cost, open for anybody to go through it and develop their application. They are open APIs, so any device, any application can plug into this by simply following the standard specification. And you see the entire gamut of countries are actually associated with this. And all the big names are associated with this, but despite that, they make proprietary solutions because these proprietary solutions enable them to lock yourself into them. Now, this is how it provides the common service layer. These are the 12 common service functions where any application need to be a registered entity. So you have to have, so you will know only authorized, authenticated applications are allowed to go into this network, and the protocols are fairly simple, which are used by HTTPS, SCOPE, MQTT, and WebSocket. These are the protocols supported, and it is open that tomorrow if a new technology is coming and upcoming and that shows promise, that will be incorporated into this. CDOT has been a member for this particular body, and we have been contributing significantly. We have 200 plus accepted agreed contributions to this standard, and we are one of the largest one to contribute to this particular standard. And this is being talked about in a big way in our Department of Telecom, and also in BIS. And very soon it might be taking shape in the form of a national standard. So this is how it works. I will simply skip this slide. So in a deployment scenario, it will be something like this. There will be multiple service providers, there will be multiple applications, and you will see there is interworking between these two. So you have an ecosystem wherein KYC, regulation, licensing, privacy, security, all are part of it, and there will be a governing body. So the governing body is also driven by the policy. Then you see everything is feeding this data, and tomorrow when it comes for the law enforcement agencies to actually have lawful interception or have a peep into this particular data, this is the only standard which can provide that. Today, WhatsApps and Facebooks of the world are not allowing that to happen. So miscreants are creating havoc by using these channels to communicate. Tomorrow, what happens is some cities, smart kind of solution, call it a smart traffic light solution, is hacked by hackers. It will create chaos without actually declaring a war against any city. An entire country will be taken for a ransom. So security everywhere. So if it is not adopted, we don't get interoperability, we don't get security, we don't get benefits to the local entrepreneurs. Only this can enable the local entrepreneurs to actually come on board and provide solutions. Regulations, implementation of regulations. And lastly, but not the least, monetization of the M2M service provider. This can only happen in a controlled manner through adoption of this. So low-touch licensing would become no-touch licensing if we don't follow this. And no transparency. Today, you don't see any transparency in any of these implementations. Thank you.
Thank you, Aurindam, Bhattacharya. We were really impressed by the details that you gave about the security aspects for the IoT devices, and also then you went on to telling us about the M2M standards and the global open standards. Also, we expect that national standards will come out finally, and the aspects regarding security were really appreciated. So now we sort of end the presentations, and we can request the audience to raise certain questions before I give my concluding remarks. So any questions from the audience?
Good evening. I am Shankar Narayan from L&T Technology Services. My question to Aurindam sir is that essentially one M2M or the M2M standards is one of, in the industry we see that as yet another standard. So how do we still manage this interoperability as a problem? Because we have another set of standards which is OCF and other set of all consortiums which are formed by the industry bodies as well as the standardization committees as well. So how do we also see that as that itself is becoming a challenge of which standards or which set of standards to adhere to?
Yeah, I was expecting that question. So OCF UA is a industrial IoT standard, right? So are other standards, but none of them actually is encompassing all. The standard we are talking about is not a use case specific or business specific standards. All standards, there are multiple standards, they have been in existence since ages. But none of the standards actually talked about a common horizontal framework which is agnostic to these such standards. One M2M is not getting in way of OCF UA, but it interworks with OCF UA. They are adapters. So your business application, your industrial IoT applications would have OCF OA built into, UA built into it. And it will have close interworking. Like vehicular domain, there are so many standards. If you see ISO IEC standards, it's full of them. But they all talk about a specific, what is within a car communication. I didn't get into those details because it would have taken a pretty long time. But within a car communication, there are standards. The frame format, the way it has to communicate, how the devices are going to communicate. See, every car will have a computer built into it, right? The sensors are primarily what? Transducers. They have to interface to some. So this standard is not going to define how your sensors are going to talk to the computer. It will talk. What it is saying that after this, when you communicate back to a platform, that leg should be standardized so that Toyota, Honda, or any other car for that matter, if it communicates to one platform, the semantics and ontology should be such that any application, any startup can then build an application, a very innovative application, and can feed from these variety of cars. So if Maruti serves a car, whatever model, whatever generation they come by, they would be able to service that particular car, right? Hope I answer your question.
Okay, any other question from the audience? So if there are no questions, I would like to conclude by saying that, in the last few years, there are several companies and entrepreneurs who have already come up in India with IoT services and applications, ranging from farming, healthcare, education, and transportation sector. The smart internet connected products have already started becoming mainstream in India, mainly due to the fact that their prices have gone down and the technology is more mature. The fast adoption and growth of internet connectivity in the past 2 years has brought more users online, which will further boost the presence of some such embedded IoT products in India. As the scaling up of the next gen IoT products happens, it will just be a matter of time before users start to experience bottlenecks in IoT security, connectivity, efficiency, and overall performance. But despite these challenges and bottlenecks of the IoT in its current state, it still has many benefits in today's businesses world, and so one needs to jumpstart on their competition before it becomes the next big thing. Thank you, everybody.
Thank you, panelists, for your valuable in-depth knowledge. With this, we come to an end of a knowledgeable session. We sincerely value your inputs and appreciate the time and efforts involved on your part to contribute to the success of this conference. Thanks to all our delegates for their patience hearing. May I now request Dr. B.M. Baveja to present the mementos as a token of appreciation to all our distinguished panelists. Mr. Aurindam Bhattacharya, Mr. Sanjay Gupta, Mr. Toshihiko Honma, Mr. Srinath Nudurupati. Now may I please request my colleague, Mrs. Aarti, to please come on stage and present the memento as a token of appreciation to our chairperson, Dr. B.M. Baveja. Well, that wraps up our day. Thank you so much for everyone to be here.